Okay, the whole point is continuous means it's one piece, there's no holes, there's no asymptotes. So what is discontinuous then? There's holes and asymptotes, which means there's more than one piece. More than one piece, right? It means it has holes or asymptotes. Right? Or it could just have one hole. But anyway. Now, which one's the removable discontinuity? The hole or the asymptote? Holes. Do you remember how you removed a hole when you were in Algebra 2? You removed a factor. So did you have to factor it and then remove the factor that was both on the top and the bottom? So removable discontinuities are a hole, and you're going to factor it out. Non-removable discontinuities are the asymptotes. And there's one other kind. It's called a jump discontinuity. That's for piecewise. That's for piecewise. Did y'all do piecewise? Okay, we'll get to it. Don't worry. When we get to piecewise, the jump discontinuity will be piecewise. So basically, if it's an asymptote, if I have an asymptote, and I graph the graph, if it does something like this, that's an asymptote, right? Yeah. And what's a hole look like? The hole looks like that, right? The jump discontinuity looks like this. So for a jump, you're going to have a line piece. It's going to be an open circle. An open circle, that's a jump. See how I went at that same x value? It's not defined at either the above or below, and I make a big jump.
Now you're thinking of portals.
And then there's a function called a step change function, a step function, where it's constantly jumping. It's one of those things where when you think about word problems that deal with people and whole things, and you can't have a part of a thing. Like, if you're buying something, you can't buy a half of a flash drive. You have to buy a whole flash drive, right? So you have to save up the money to get a whole flash drive. So it's actually a step change. You have to have enough money to buy a whole flash drive or enough money to get a second flash drive. There's no in between. There's no buying half of one. So those are step changes. All right, now we're going to talk about linear functions. The easiest one, the one you've done for forever and ever and ever and ever and ever and ever, 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 right? And what's the equation of a linear function? You may remember? Huh? No, I want the general equation. Y equals mx plus b. What's the parent function? Y equals x. So we're going to use y equal x right now. But is the general equation y equal mx plus b? What's m? Slope. What's b? B is the y-intercept. I can't, hang on. It's the y-intercept. So the way I think about this is b is where I begin. Do we begin at the y-intercept? And m is how I move. Is that showing you how to move between points? All right. For any line, what's the domain? Y'all did this all during Algebra 2. What's the domain? What are the x's? Are there any restrictions? No. Okay, if it's all of them, how do you tell me it's all of them? All real numbers. There's two ways to do it. We can say all real numbers. So the domain, you do D for domain. You do colon, and you do all real numbers. Or you do negative infinity to infinity. I need you to get used to the negative infinity to infinity. Why? Because this is pre-calculus. Presumably this class is to lead you to calculus. And in calculus, you need to know that notation, the negative infinity to infinity. What's its range? And actually, this right here, there's actually a whole nother there's notation. Actually, let me show you notation. I'll show you set notation just for giggles. I'm not going to make you do this. But the way it's supposed to work, you're supposed to say domain, and you're supposed to say X is a set of the all real numbers, and then range, Y is a set of all real numbers. But we don't have to be that fancy, do we? Just tell me all real numbers. Just if you just give me the funky looking R, it's not just an R, capital R. It does have that extra mark there. That is the symbol that means all real numbers. If you just write that down, I'll be good. And I need you to know set notation. I mean, not set the inequality, the way we show it, right? Negative infinity to infinity. I need you to be able to give me that notation also. Everybody understand? Okay, specifically to our parent function, what's the x-intercept? By the way, let's graph it. Shall we graph it? Oh, yeah. Okay, for this one, is it easy enough to graph without making a little table? But if you had to, could you come over here and go x, y, and put in my favorite numbers? My favorite numbers are -2, -1, 0, 1, and 2. It's -2, -1, 0, 1, and 2, right? -2, -1, 0, 1, and 2. Yes? Yes. And I think I have a shape. Can I put a line in? Oh, I can. Let's try a line. Okay, we now have a line. Did I do good? There we go. Is that the line y equal x? Everybody see it? And when we're talking about M and B, all we're doing is we're changing where it crosses the y-axis and its slope, how it's tilted. What does a positive slope look like? Is it the same as this? Goes up from left to right. What's a negative one look like? Goes down. Yeah? All right. So x-intercepts what? Where does it cross the x-axis? 0, 0, right? What's the y-intercept? Where does it cross the y-axis? 0, 0. Because now, if you have a different line, will you have an x and y intercept? Yes, besides 0, 0. In behaviors. In behaviors, when it says plus infinity, it means I am going to the right. I'm going to infinity. Right? Going to plus infinity. This one says I'm going to the left, which is negative infinity. So if I'm going to the right, what's my y value going to? To infinity. If I'm going to the left, what's my in behavior? What's it going to? Negative infinity. Does everybody see that? So the way we write this is, as x goes to infinity, y goes to infinity. As x goes to negative infinity, y goes to negative infinity. Increasing intervals. Where is it increasing? Is it increasing the whole time? Okay, so the increasing interval, when I want interval, that's interval notation, that's this one. It's the going from negative infinity to infinity. Are there any places where that line is decreasing? Okay, you write none, and I expect you to write none or NA. Your choice. Continuity. Is it continuous everywhere? Yes. Then you tell me continuous, it's from negative infinity to infinity. If it's not continuous, you tell me it's continuous everywhere except, and you tell me where it's not continuous. Does that make sense? Everybody clear on that? Sort of. Okay, are linear easy? Yup. Those are the easy ones. What's new? Nothing. Y'all have seen all of this. But I'm expecting you to be able to graph it quickly and answer all those questions. Looking at that graph, could you answer all those questions, and do you have to get used to writing it the way I want it? And why do I want it this way? Because when you go on to an advanced class, that's what you're expected to be able to do. I know this because I teach the advanced class. I teach both versions. Okay, for our next function, do y'all know quadratic functions? You do. You know it. You know it. You do. Okay, quadratic functions, that is y equals some constant, yeah, some c x squared plus some, oh, hang on, let me see, what do we call this? Actually, we call that a. That's ax squared plus d, I think. You know the transformation equations, right? Actually, let's go ahead and do that. Why don't we write it down? This is what you learned in Algebra 2. You learned that it was a times x minus b, no, it was b times, hang on. I'm trying to remember how y'all should have been taught it, and y'all tell me if y'all learned something different. It should have been b times x minus c plus d. Did y'all learn that? We learned it in here when we did trig, but did y'all learn that in Algebra 2? You were supposed to. Something along that line?
Yeah, I remember this, yeah.
Yeah? Okay. The A is the vertical stretch, right? And if it's negative, it means it reflects across the x-axis. Remember that? B is the horizontal stretch or compress. C is how much I'm shifting left and right, and D is up and down. We've done this before, right? Okay. The equation for the parent function, so this is parent, is y equals x squared. Can you graph that really easily? Yeah. If it's like Jerice definitely can, because he graphed that a gazillion times without any means of support. So if you don't know how to graph it, can you make a table? Now I'm going to show you, everybody just watch. I'm going to show you how fast I can graph it because I really know this one. I know that 0 squared is 0, so I'm going to make this big so y'all can see what I'm doing. I know I start at 0, right? I know if I have 1 squared is 1. I know that 2 squared is 4. I know that 3 squared is 9. And then I'm going to duplicate them on the other side because negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9. And I can draw in my parabola, right? I can draw it better when I'm not doing this thing. But, so what did I do? My favorite numbers, I did a little bit more. I did negative 3, negative 2, negative 1, 0, 1, 2, and 3. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 is 0. And then this is 1, 4, 9. And I graphed them. So if you have trouble, make a table. If you can do this without the table, by all means, do it without the table. If you can literally, for the quadratic, go 1 squared is 1, 2 squared is 4, 3 squared is 9, graph the points. Now, when you're graphing these for me, do you have to show me some points? You need to make sure I can see what you are graphing through so that if you make a mistake, I can see where you went wrong. Are we clear? Because we're not going to just stop with these parent functions, are we? No, we're going to transform them. That's what's coming. It's what you did all of Algebra 2. All you did was learn a new function, transform it. You shifted it, you flipped it, you stretched it, right? You compressed it. You did it over and over again. You started with absolute value and kept going. Yes? Well, guess what we're going to do in here? But I'm going to do a quick review of everything y'all were supposed to learn, and you're going to have to do it by hand now. I'm not sure what y'all did in your class, but you're going to do it by hand. Got it? Okay, it takes practice. All right, so going through looking at this function, can you look at that right there, and can you answer these questions now? What's your domain? Does it go forever and ever to the left and ever to the right when we're talking about that graph? So what's my domain? Negative infinity to infinity, right? Okay, for the y, is a negative value possible? If you're squaring this thing, can we have negative values? No. So my y has to start, can it be 0? So does it have to start at 0, go up? How do we write that? 0, comma, infinity. we're going to go to infinity and beyond. Now, I messed up. Okay, I've been using open parentheses because infinity is not a real number, but is 0 a number? And do I want to know whether it's included or not? And how do we indicate that? With the square bracket instead of the curved bracket? I mean the parentheses? Yeah? Okay, so we want to show that that point's included because it's possible. On some of our functions, it's not possible, right? Okay, x-intercept. What's the x and y-intercept on this? It's the origin, 0, 0. Does everybody see it? All right. What's the end behavior? As x goes to infinity, what does y go to? Infinity. Does everybody see it? It's going up. As x goes to negative infinity, what's y going to? To infinity. So look, well, here's what we're doing. As x goes to negative infinity, what is y going to? Infinity. As x goes to positive infinity, what's y going to? Infinity. Does everyone see it? Is that my end behavior? Now, here's something I'm going to lay on you. This works for every even function. Do you remember cosine? Okay. I mean, not cosine. Cosine's not. But I mean, if it was x to the fourth, do you remember when you learned end behavior? For x to the fourth, does it do the same thing? Does x to the fourth have the same domain, range, end behavior? It does. Increasing, decreasing? Yeah. As long as it's just x to the fourth. Whenever I start to do anything else to it, it's going to go. Actually, x to the fourth kind of be. Anyway, the parent function goes. Is the end behavior the same? Yes. Any even function. What's an even number? It's 2, 4, 6, 8. So x to the 12th. Does it have the same end behavior? Yeah. All that happens is in between you get all these weird humps in it, but it's going to go as long as it's even. All right. Last thing, increasing. Where is this function increasing? So as I move from left to right, is this first part on this left-hand side, is this increasing or decreasing? It's decreasing. So how do I write that? My interval of decreasing is negative infinity to 0. And you don't include 0 because it's neither increasing and decreasing there. That's where it changes, right? You can write it as a square bracket. I won't take off. But it really isn't included. So where is it increasing? If I go from 0 to the right, is it increasing everywhere? So that's going to be what? 0 to infinity. Is this function continuous? Yeah, what's it continuous on? What's the interval? To draw that, did I pick up my pen? Are there any holes? Are there any asymptotes? Are there any jumps? Nope. Then it's continuous over the whole interval, all real numbers. And how do we write that now? Because y'all were just writing down all real numbers, and your algebra teachers algebra 2 teachers were so happy you could even say that, and I want more. I need you to write it as negative infinity to infinity. Got it? Okay. Additional information. I really don't have anything else on this one, so we don't really need that on this one. That's not too bad, is it? No. Okay. This is where we're going to stop today. Okay? Because I want y'all to work on your graphing. So what I need you to do now is I need you to switch to the homework assignment, and we're going to work some of those together. Okay? So while you do that, yes, I am going to pause the recording. No.